Good morning to everyone. Welcome to today's session on machine learning and its algorithms. I'm Nivedita, Assistant Professor in the Department of ECE, Hindustan College of Engineering and Technology. This presentation gives you an introduction to machine learning along with a wide range of machine learning techniques such as supervised, unsupervised, and reinforcement learning. So again, these are the topics that will be discussed in the presentation. First one is what is machine learning, followed by history of machine learning, how does machine learning work, need or importance for machine learning, classification, followed by the applications of machine learning. So yes, what is machine learning? Machine learning is a growing technology which enables a computer to learn automatically from the past data. So here machine learning uses various algorithms for building the model and making the predictions using historical data or information. So currently it is being used for various tasks such as image recognition, speech recognition, email filtering, Facebook auto tagging, recommender system, and so on. So again, in the real world, we are surrounded by humans who can learn everything from their experiences with their learning capability, and we have computers or machines which work on our instructions. But can a machine also learn from experiences or past data like a human does? So here comes the role of machine learning. So this picture actually interprets beautifully what machine learning is. So machine learning is said to be a subset of artificial intelligence that is mainly concerned with the development of algorithms which allow a computer to learn from data and past experiences on their own. So the term machine learning was first introduced by Arthur Samwell in 1959. So this is about the what is machine learning is. Next comes the history of machine learning. So we have, from 1834, we have a lot of evolutions of machine learning. So we just quickly brush up the evolutions. In 1834, Charles Babbage, the father of computer, who conceived a device that could be programmed with punched cards. However, the machine was never built, but all the modern computers rely on its logical structure. Again, in 1940, the first manually operated computer, ENIAC, followed by EDVAC, were invented. And in 1943, a human neural network, which was modeled with an electrical circuit, was invented. And in 1950, Alan Turing, he published a paper on computer machinery and intelligence on the topic of artificial intelligence. And when we go through this paper, he asked a question that can a machine think? And so again, in 1952 and 59, sequentially, we have, Arthur Samwell. He created a program that helped an IBM computer to play a checkers game. So, like machine learning was first coined by Arthur Samwell as well. Again, when we take the period between 1974 to 1980, it was actually very tough time for AI and ML researchers, and this duration was termed to be AI winter. In this duration, failure of machine translation occurred, and people had reduced their interest from AI, which led to reduced funding from the government to the researchers. So this is AI Winter's era. And moving on to 1959, we have first neural network that was applied to a real world problem to remove echoes over phone using an adaptive filter. So this was done in 1959. And moving on to 2006, we have a concept called deep learning. And nowadays it has become one of the most trending technology. Again, in 2012, Google created a deep neural network which learned to recognize the image of humans and cat in YouTube videos. So again, in 2017, we just came across online trolling. And when we take machine learning at present, it has got great advancement in its research, and it is present everywhere around us. For example, if we take self-driving cars, Amazon Alexa, Catbot's recommender system, and many more. So all these things will include supervised, unsupervised, and reinforcement learning. So this is about the history of ML. When we move on to the next slide, we have how does ML work? So here, machine learning system learns from historical data, builds the prediction model, and whenever it receives a new data, predicts the output for it. So, the accuracy of a predicted output depends upon the amount of data, as a huge amount of data helps to build a better model which predicts the output more accurately. So, for example, suppose we take a complex problem where we need to perform some predictions. So, instead of writing a code for it, we just need to feed the data to certain algorithms, and with the help of these algorithms, the machine builds the logic as per the data and predict the output. So machine learning has tremendously changed the way of thinking about a problem. So this is about your machine learning block diagram. Again, it can learn from past data and improve automatically. And machine learning is much similar to data mining because it deals with a huge amount of data. So this is about the block diagram. Next comes the need or importance for ML. So the need for machine learning is increasing day by day. The reason behind it is that the need for machine learning is it is capable of doing the tasks that are very complex for a person to implement directly. So as a human, we have some limitations as we cannot access a huge amount of data manually. So for this, we need some computer systems, and here comes the machine learning to make things easy for us. Here, we'll be training the machine learning algorithms by providing them the huge amount of data and let them explore the data completely and construct the models accordingly and predict the required output automatically. So here the performance of the machine learning algorithm depends on the amount of data, and it can be determined by the cost function as well. So with the help of machine learning, we can save both time and money. Next comes about the classification of ML. So the classification of ML is like we have three different types: supervised, unsupervised, and reinforcement learning. So let me explain one by one in the following slides. Next one is about supervised learning. Here I have taken the fruits as an example. So supervised learning, as the name indicates, as the presence of a supervisor as teacher. Basically here supervised learning is when we teach or train the machine using the data that is well labeled. So which means some data is already tagged with the correct output or answer. After that, the machine is provided with new set of examples, that is the data, so that the supervised learning algorithm analyzes the training data, that is the set of training examples, and produces the correct outcomes from the labeled data. For example, suppose you are given a basket filled with different kinds of fruit. Now, the first step is to train the machine with all different fruits we have. For example, if you take an apple, if the shape of an object is round and has a depression at the top, when it is in red color, then that fruit should be labeled as apple. Next again, if you take in a banana, if the shape of an object is like long, curving cylinder which has a color of green and yellow shade, then it should be labeled as banana. After all this, after training the data, if we give a new separate fruit for testing, say banana from a basket or apple from a basket, and ask to identify it. Again, since the machine has already been learned the things from the previous data, and this time it has to think or use it wisely. So it will first classify the fruit with its shape and color and would confirm the fruit name as banana or apple and put it in the banana category or apple category. So that's the machine learns the things from training data, that is a basket containing fruits, and then applies the knowledge to test the data which we have given as a new fruit. So this is about the supervised learning. And supervised learning, we have to remember a keyword called labeled data set. So here it has two important algorithms. One is classification, the other one is your regression. Next comes the unsupervised learning. So here, suppose unsupervised algorithm is given the input data set containing the images of different types of fruits. We have taken apple, orange, and banana. The algorithm is never trained upon given data set previously, which means it does not have any idea about the features of the data set. So the task of your unsupervised learning algorithm is to identify the image features on their own. It will perform this task by clustering the image data set into groups according to the similarities between the image. So actually the machine has no idea about the features of apple or orange or whatever. So we can't categorize it as apple or orange simply. But it can categorize them according to their similarities, pattern, or differences. We can easily categorize the above picture or given picture into two parts. The first may contain all pictures having apple in them, and second part may contain all pictures having orange in them. So likewise, we can just cluster the given data set into accordingly. So it allows a model to work on its own to discover the pattern and information that it was previously undetected. So here we'll be completely using the unlabeled data set. So we have two important algorithms, clustering and association. So famous clustering algorithms are like K-means clustering, principal component analysis, singular value decomposition, independent component analysis, and so on. So this is about unsupervised learning. Next comes the reinforcement learning. So here in the again in the reinforcement learning, it is actually feedback based machine learning technique. Here the agents learn to behave in an environment by performing the actions, and it will be visibly seeing the results of the actions performed. For each good action, the agent gets positive feedback, and for each bad action, the agent gets negative feedback or penalty. So here the agent learns automatically using feedbacks without any labeled data, unlike supervised learning. So since there is no labeled data, the agent is bound to learn from its own experiences. So suppose, for example, there is an AI agent present within maze environment, and his goal is to find the diamond. What the agent does is it interacts with the environment by performing some actions, and based on those actions, the state of the agents gets changed, and it also receives a reward or penalty as feedback. So as a positive reward, the agent gets a positive point, and as a penalty, it gets a negative point. So this is all about reinforcement learning. And the last one is about the applications. So the importance of machine learning can be easily understood by its use cases normally. So currently, machine learning is used in self-driving cars, cyber fraud detection, face recognition, and friend suggestion by Facebook. And again, various companies like Netflix or Amazon have built a machine learning model that are using a vast amount of data to analyze our interest, that is our customer or user interest, and recommend the product accordingly to our interest. So this is about the applications of machine learning. Thank you for patient listening.